I'll do a little processing on that too. And I guess what I should mention is the equipment I use to collect data. And let me pull up a picture of that. My telescopes. Let's see. What should I use here? I have a, yeah, this should be good. Yeah. So this is the equipment that I'm using. It's a 10-inch Ritchie Chrétien on a Lost Mountain DG11 mount, and I'm using. I have two ZWO 071 cameras, a Lodestar camera, a Canon T3i that's piggybacked on top. This system is fully automated, and I can run it. I can run it from my house. The laptop on the desktop is what runs the entire system. So I just remote desktop into that laptop to run this thing. And I can set up a script so it'll run all night and I can go to bed while it's running. And it handles everything. It does automatic focusing, automatic meridian flips, reacquires the data, plate solves to reacquire positioning, the whole 9 yards, and then it parks itself when the sequence is done. So that's how that works in the morning, or when I'm not awake. Last Saturday I did everything ad hoc, and I was live with that. And then when we shut down at 12:30 last Saturday, I had two more objects that I put into the sequence, and I let it run while I went to bed. And that was M81 and I think it was M101. Is that the two I get? Yeah, something like that. Maybe I don't remember. There were two objects that I got in the morning hours. I'd have to go look at my list here. Was it M106? Was it no 101? It was M65, and then M101. Those are the two that went in the morning after we shut down the feed. So feel free to put questions in the text chat as we go along. So anyhow, that's the telescope I used for that last weekend. And so we'll get started here. Now, during the data acquisition, the 071 camera is a one-shot color camera. It's the size of an APS-C chip, which is basically 23 millimeters wide by 17 millimeters high. Okay, so it's a rectangle, 23 by 17 millimeters. And the scope is running at 2,000, approximately 2,000 millimeter focal length. So the images that I take that we saw last week are all raw lights. And those raw frames are all in what's called FITS files. And we're going to go here. And we're going to bring up M1. So last week, all these little blue diamonds that you see are the FITS files, the raw data. And we took each of these were 2 minute for subframes, and we were at a gain of 300, and the camera was cooled to -5C. And we took I think 20 of them, or what do we? 15. We had 15 of them. Yeah. And so we only ran about 30 minutes on this object. But previously, last month, I took darks for 5 different exposure times: 1 minute, 2 minute. In fact, let's go here. Go to my dark frame library here. We took 1 minute. Maybe I should make these bigger. Yeah, I guess I can't make that big. 1 minute, 2 minute, 3 minute, and 5 minute exposures at a gain of 300. And the way you take darks is you can do it anytime. You just cover the scope and you set up a script to take your exposures the same length of time that your lights are going to be. So 1 minute lights, 2 minute, 3 minute, and 5 minute. That's typically the four exposure times that I use for my objects. Sometimes I go less, like 30 seconds for uh, brighter things. So you set up all those darks, and in this case, we're going to use 24 darks for this first processing, and they're all 2 minutes. And then the flats, you take those whenever you change your optical system. In other words, if you take the camera off, fiddle with your system, and put a camera back on, you're going to have to take flats again to eliminate any of the gradients. And gradients are things like dust donuts. Um, here's a worst case scenario I took last year. Where is it now? There we go. Of gradients. You know, all these little rings or dust donuts that are part of the optical path somewhere. There's some bigger rings in here, which means they're further upstream. And I know where these dirt donuts are. These that are about the size of a 1 inch on my screen, they are on the filter, the UV IR cut filter. That is actually no, these are on the AR window that's approximately 17 millimeters in front of the chip. These bigger ones are on the UV IR cut filter that is approximately 41 millimeters in front of the chip. The big donut is the obstruction. The big donut is the central obstruction of my telescope, and then off in the corners is vignetting. And these flats, in fact, there's a huge donut over here that is probably a speck on the on-axis guiding port mirror. So I have lots of surfaces that a dust donut can show up that's fairly close, relatively close to the chip. The on-axis guiding port's about 60 something millimeters off the chip. Anything that's on the primary or secondary mirror never shows up. They're just too far away and not even focused. And these are getting closer and closer to the focal point. That's why they show up. So that's a flat. And the reason you take 50 of these is so that you can effectively subtract all these artifacts out of your final image that will be there in the dark frame or the light frames. So that's a little bit about the flats, why you take them. Now, granted, I take flats. It makes me lazy, so I don't clean the the optics as often. But sometimes when you go to clean the optics, you may get rid of some of the artifacts that you saw there, some of the dust donuts, but you may introduce other ones. So it's kind of one of those things where you say, well, if it gets bad enough, I'll clean it, but I'm not going to worry about it right now because my flats take care of it pretty well. So those are three elements that I use for data acquisition. There are people that use bias frames and dark flats, and I have not gotten into those two and don't even know why you would use them at this point, so I'm not even going to address that. But like I said, I'm talking about beginning to intermediate data acquisition and processing here tonight. So once we've acquired that data, we want to put it together and process it. And part of that is stacking. And what does stacking do? I'm going to stack 15 images here of M1. So I'm going to pull up the M1 data that we took last week. Let me get this details type. We're going to pull up the FITS files. Okay, there's 15 of them. And I'm going to do this stacking in oh, I pressed the wrong one. I'm going to clear those, clear list. I'm going to do this stacking in Deep Sky Stacker, and here's the reason I'm doing it here. In Deep Sky Stacker, you load up the lights, the darks, and the flats. And if you want, you can check every frame in a FITS viewer, or even right on here. When you load them up, you can look at each one. If you want to negate any one of them that looks like a bad frame because it's drifted too much, the stars are oblong, or you have a big satellite go through, you can remove them. and not stack them in the frame. Or you can tell it to stack some percentage of the frames that you have. So let's say I have 100 of them, and I want it to stack the best 80%. So I can set it to 80%, and it'll stack it scores every one of them by some algorithm it's got, and it only stacks the best 80% or best 50%, whatever you're going to do. In my case, I have my system set up so that if the only time I would have to remove one is if during an acquisition I got clouds rolling in over it such that it acquired the data, but its background got very bright, and it kept it. Because right now I have the system set up so that if the guide star goes more than 2 pixels out during guiding, it will throw that frame away and start it over again. So I almost always have 100% good frames as far as tracking is concerned. The only time I have issues is if I get some satellites through, or some high Cirrus that comes through, and I kind of want to throw away those bad ones. So I may go 80 or 90%, because it'll throw the low scoring ones away. So anyways, we're going to open up these 15. Then we're going to open up our dark files. So I'm going to go back to my dark library here. And these were 2-minute exposures, so I'm going to pull up the 2-minute darks. There's 24 of those. And then I'm going to open up my flats. And with a new alignment, yeah, this is the set that I want. There's 50 of those. By the way, when you take your flats, my dynamic range is between 0 and 65,000 A to D counts, or ACUs they call them. And I try to take my flats right around 20,000 or between 20 and 24,000 ADUs. And the way I do that is as they're coming off the camera when I'm doing the flats, is I just put my cursor around on the frame and look at the ADUs counts at the bottom. And yeah, okay, that's what I want. And then I run a 50 frame run on for that setting, and then I'm done. So I'm going to open these. And I did these flats back in February because I don't change my system. It's in the observatory. I never touch it. So these flats are still good. So now if I scroll up here, you'll see that I've got my M81 shots. Why is there only 10? I thought we had 15 of these. 321. Did I miss them? M81. Oh, I was going to do M1. That's why. My bad. Do M1 first. That's what I meant to do. There we go, M1. So I'm going to pull these 15 up. And I'm going to get rid of these M81s. So I'm just going to highlight them and say remove from the list. Okay, so M1 is down here at the bottom, and there should be 15 of them. So when I check all, it should pop up here and say light frames 15. Good. So that's what we want. Now, if you look at the raw data, I'm looking at the raw data right now. This is what a single frame looks like. And I'll maximize this now. So the single frame looks like unstretched or anything from the FITS file. So this is what the raw data looks like. Oops. Gotta make sure we do this right here. There we go. This is what the raw data looks like. Hi, Diane. This is the crab then. Raw data, unstretched, unprocessed, just a single frame. And I'm looking at all these right here. So they look okay. We're going to use them all. So at this point, they're ready to go. I'm going to say register, and I'm going to say use 100% of the pictures and stack them. So we'll just let that run. It'll only take a minute here. So it's going to register the 15 frames, which means it's looking at all the stars down to a certain magnitude, matching them all up against each other, against one master. It picks one of the highest valued ones. And then it's going to stack them all. So right now it's registering them. And now it's going to stack them. And at the same time, it's applying the darks and the flats to each frame. So it's doing all this work for you just by hitting that register check picture. It's registering them, applying the darks, applying the flats, and stacking them. And it's going to create one output file. It's a TIFF file that I'm going to then use in PixInsight. And the reason I use this tool is in order for me to do this in PixInsight, they do have a preprocessor now that does a lot of this, but it's still a multi-step process. Oh, the other thing DSS is doing here is it's debayering it. In other words, it's creating the color image too. When I had to do this in PixInsight 2 years ago, I had to debayer all the frames. Then I had to stack all the had to register them all, then integrate them all before I could start processing them. And that took a lot of time. This does it all in one shot. And that's the reason I use it. And I don't use Deep Sky Stacker to do any processing, just do the stacking. It's doing the 3-channel alignment of the colors. And saving the image away. And then it'll display the stacked image. And the stacked image won't be processed. It'll be stacked. So I've taken all 15 frames and put them together. And when they stack using an average or a median, depending on what you want to how you want to do it. They don't add data. They don't add, because if you did that, after 20 frames, your entire screen would be white. They average the values. They average the values out. So there's the stack image there. If you remember the single frames that we showed you, they were FITS files. This is a stack and it's in color. Okay, so that's before I even do any processing. That's actually kind of nice. Now I'm going to go over to PixInsight. And we're going to maximize this guy, and we're going to open that file up that was just created. Let me make sure I'm on schedule here. What do we got here? Stacking. Yeah, so you can stack in Deep Sky Stacker or PixInsight. And I wasn't going to go through the stacking process in PixInsight. It's doable. I just prefer using Deep Sky Stacker. So in processing, we're gonna pull it up now and do these five or maybe 6 functions. We'll see, and it really depends on the target. So we'll go here, M1, March 21st, and autosave 001.tiff is the file we just created, and we'll pull that up. Now when it comes in here, it will be the raw stack with no processing, so it's going to be dark. And I'm going to show you something. I'm going to do an auto stretch, which means it's going to maximize the stretch without any intervention. It's an automatic auto stretch. And what you're going to see is that it's going to have this big old green background. And that's because it's an RGB Bayer matrix. Two greens with an R and a red and a blue. And that's how it comes out when it's debayered. So what we'll do is we're going to take this and we're going to apply, the simplest case is we're going to apply automatic background extract, which basically does a color balance, a somewhat color balance, but it normalizes the image and takes out some of the gradients. So let's go ahead and hit this, and then we'll see what it looks like. It's going to create a new file in memory. Hopefully you can all see this okay. Okay, so it just created a new one. I'm going to do an auto stretch on this. And there you go. So the green's gone. Most of the gradients are gone. This is a little bit overexposed as far as stretching is concerned, but that's a max stretch. And that I do that real quick just to see how it worked out. And this will be fine. There's another couple of tech tools called photometric color calibration. I will use that to get a better color balance of, because what it does is it uses the stars in the field of view against a database that has photometric data for a lot of the stars, and uses a reference point to give a better true color calibration of the object and the surrounding stars. But the simplest thing is this auto background extract gets the color balance somewhat close. Now we'll minimize this. I'm going to do one other thing. Now I'll do that in a minute. I can show you I can back up. So we'll go to histogram now. So we've done the auto background extract. I should show you the color calibration. I'll show you what that does. So let me do that. So I'll bring up color calibration. I'm going to do the simple color calibration. And what that is you identify an area of the screen that you want as your primary color and then your background color. So I'm going to pick Crab Nebula and some of its surrounding area. In fact, I'm going to move it. Oops. That's not what I wanted. Hang on a second here. Delete all. All right, so I'm going to pick that star, and this object as part of the foreground. And then I'm going to pick a small area over here that's kind of part of the background. And then I'm going to go into the color calibration tool and identify those for this tool. Preview 1, preview 2, and then we'll just hit the little rectangle or the square and say go. So it's going to go out here and it's going to do some magic. Okay, and now when I auto stretch it, we'll see what it looks like. Now what it did, it moved it a little bit into the blue, out of the green into the blue. So that background is actually a little bit more, it's subtle, but it is, I can tell that it did change it. It's got a little bit more blue in it now. So if you like that, again, when you're processing data and you're a different user, five different people processing the same data, probably will not get the same results. A lot of this is art. So anyhow, I'm going to turn off the auto stretch, and then we'll do an actual stretch, and that's with the histogram here. So you'll notice I'm going to bring these little arrows that are in the graph. I'm going to use them to stretch the data here. We hit there. Okay, so now we got that so far. I'm going to bring up the bottom a little bit to get it darker. Bring the top down to get a little lighter. As you can see, you can start seeing the filaments in the crab now starting to show up really kind of nice with a reasonable color balance. It's not purple, it's not green, it's kind of a reddish that you would expect. Yeah, maybe we'll go right about there. So this is art too. Do you want to have it real bright in the background, or you want to have it real dark? So you'll kind of pick a spot that you think is reasonable. Again, that's art. So I like the little darker background, as long as I don't lose too much of the data in the nebula itself. So I'll hit that. Okay, so that's the histogram, simple stretch, and we're going to go to the curve transformation. We'll do curve transformation here. And what I'm going to do here is I'm going to use the saturation. So watch the color in the nebula as I move this. See how I can increase the saturation of the colors of each of the objects, including the stars. I mean, the red stars are getting really reddish orange, and the blue stars are getting bluer. The red in the nebula is getting redder. I can make this so extreme that it looks clownish. So there's a nice clownish look at it, right? But what I like to do is keep that a little more subtle. So I've increased it just a bit to get so you can tell there's color in the stars. Um, and I usually hit it right there at this one spot almost every time because that's kind of how I like it to look. In fact, the blues in the nebula comes out a little bit too. So if you notice in the histogram, the blue spread out and dropped down. So there's a lot more blue in here now than than there was before. And there's not much more I do in the color. Sometimes I may mess with the luminance a little bit just to brighten it up or darken up the background. So you can play with this and do all kinds of stuff. There's here I'll make it really dark, right? Really dark background. Again, this in my mind this is all personal preference. How do you want it to be rendered? So I like a little bit darker background, so I did that. And if you saturate the top end a little too much, it blows out the middle of the nebula. So you want to be kind of careful about that. You know. But we'll just darken it up just a bit. There, about right there. Bring the top up a little bit, and we'll call that good as far as the stretch. Now the only other thing that I do sometimes, and it depends on how it really depends on how it looks. So I'm going to zoom. Let's see here. I'm going to shut off my previews here. I don't need them now. I'm going to zoom in here, and as you can see, you get in here really tight on a zoom. It's pretty noisy, but it's also not very sharp on the little filaments. And I'm not going to be able to get it much sharper. I'm pretty good focus. All the stars are nice and round, and they're good guiding and everything like that. But I don't think I'm going to get it much sharper. But there are some fun tools you can try. Here's an unsharp mask, and unfortunately I can't zoom in to show it here, but you can sharpen up the image, but it introduces noise. You notice if I back this off, the nebula gets pretty soft. If I go extremely here, it gets a little sharper, but the background looks, it looks like you've thrown pepper on it or something. So I don't use this very often, but once in a while I will. At this point, I'm going to leave it alone, but I wanted to show you what it would do. And what I will do is I'll execute a simple, because I can always back this off, but I'm going to execute this unsharp mask, and we'll see what it does to the nebula here. When you look at it, it'll if you watch it carefully, once it's done, it'll look like it just added noise to it. It didn't look like it did much, but add noise. So I'm going to Control Z, which takes it away. Okay, so it softens up a little bit. The other tool that I sometimes use is the deconvolution. And I just use the defaults that are on here. So, and I'm not even going to go through what they are because personally, I don't even know. I just like what it does sometimes. So I'm going to execute that. It'll take about 20 seconds to run through this. But watch again the filaments in the nebula. See if that actually improves it at all once it gets finished. And like I said, this is the simplest process that I've come up with for doing my process. As you can see, I've already got the data really where I want it. And now I'm just going to look at some tweaking things that I may or may not even do. The unsharp mask, the deconvolution, I may not even use it for this object. Sometimes it depends on what the data set looks like. And some of you know I've taken data all the way up to 12 hours. Not intentionally, but I have. I think I have found kind of sweet spot for my stuff. If I want kind of a pretty good looking image, is about 4 hours. I can do 2 in a night. Now, see what that did? It did introduce some noise, but it did sharpen up a couple other things. But I'm going to go back it off. Look at it now, and then I'm going to back off what it just did. Okay, it's almost no change. So in that case, if it's no change, I don't want to add anything to the data set. So I'm basically done with this. And what I usually do is I save it away as an EXIF file, so it saves all of the changes I made that I can use again from that point forward. And as a matter of fact, I've got one sitting here already, and I'm going to call it second processing because it's a new processing. And what I'm going to do is I'm going to pull up the other processing between the two, and we're going to look to see how much different I did from the last time. And I think I did it differently. So let's pull up the old one. Yeah, from a week ago. And let's compare the two. Okay. Yeah. See, I can already see what the difference is. Right? The new one I just did has got a darker background. Right? So that's what you call variability of the user. But it's got similar color. The background's a little darker in the one I just did than the one I published a week ago. And that's one of the problems. When you get a human involved, it's never the same. This one looked kind of good for me when I looked at it last. Actually, this one looks different. The little color balance is a little different too. So anyhow, so those are the two things that can look different, just based on what you did that night. And I have another example of that when I did my M81 before last week. I did another version of it last month and the month before, I think, or whatever. I compared what I did before to what I did last month. Totally different color balance, and I did that on purpose to see what the different technique was using the photometric calibration or color calibration versus not using that, and the color balances was completely different. And I published that on the Warren Club Facebook page. The two, you can go and look at those. So what I'll do now is I save the EXIF file and then I save a JPEG version of it. And the reason I'm going to do that is I'm going to show you I have one more tool that I use that's outside of PixInsight. PixInsight has a tool to do this. I haven't discovered it yet, and I haven't used it yet, but I know it exists because other people have talked about it using the noise reduction tool in PixInsight. I've just never bothered with it yet. This is one of the fun things about getting into this. I've been imaging with this setup now for 3 years and these tools. And every time I do this, I learn something new every time. I learned something new today in the other meeting I was in. But what I wanted to show you is I have this tool called Topaz Labs Denoise. And I wanted to show you what it does. So I'm going to pull this up. Going to pull up this new JPEG file that I just created, and it's second processing. It's this one right here. So this is an added starter for your enjoyment here. And what it's supposed to do is eliminate some of the noise, right? So I'm gonna hit this auto button and see what it does. So if I go back and forth, it supposedly eliminated some of the noise. What I found is sometimes it does a really good job of this. Sometimes it actually makes the noise worse. I'm going to slide that bar over, and now you can see on the right-hand side where, it gets rid of the noise, but it makes some really dim stars look really goofy, whereas the stars are not so goofy looking on these dim ones. But it does smooth it out, and I'm not sure. I don't always use this, but sometimes I do. If I've got 4 hours of data, I almost never need to use this. That was just an example, and I'll save it away so we can take a quick look at it in regular view. Because in this zoomed in view, it's not very useful. So it's actually doing the entire image now. It's processing that image with that setting. And I slid that remove noise bar quite a bit, more than I normally would do, because I wanted to see what it does in the final image. 70%. Any questions so far? Text in either YouTube or in the Discord. Not too much in YouTube right now. Okay, so I'm going to close this window. And I want to look at this data now. One. Okay, let's slide through this data here. This was the one I just processed tonight. Here it is in through after the denoise. I'll go back and forth on it. There's a slight change. I think it gets blurrier, less noise but blurrier. So that's yeah, Ken, Topaz and JPEG. I think it can read TIFF files too. So I would keep the original and not use the denoise on that one. But here's the last week's processing and last week's denoise. So it's a very subtle difference. Hi, Riyadh. So that's basically that's the Crab Nebula that we took last year or last week, and I just processed it again. Any questions about this? Okay. Well, um, I'll let the YouTubers catch up here. As soon as I see it show up there, then I know the question's being asked. I've used up 35 minutes. So I don't think I'll do M81. What I think I'll do is show you what I do with the comets, because I do a lot of comet work, if you're interested in me doing that. Silence. Okay. I'm going to close this. Close this. I will use the comet from last week, and we'll just go through a quick demo of that. So the first thing I do is I pull up the Debayer tool. I set my mosaic pattern to RGB. I add the files, and this is the these are the files I had. So I add all these files into this and then execute this process. What comes out of it is a list of debayered files. You can see that there's a D at the end of the file names here. That means they're debayered. So that's what adding the files in here and then just executing it to an output directory. That's how I do that. Okay. I'm not going to go through it. It takes a little bit of time. And then once the debayer is done, which means I've turned them in those files into color, they're now color, I use a tool called Comet Alignment. And I'll add the files under the debayer. I'll add these files in like so. I pick an output directory, but the very first thing I do is I take the first frame of this object. I'm going to do an auto stretch so I can make sure I got the comet in here. So this is a raw debayered file. And I highlight the core of the comet. The first frame, and then I scroll down to the last frame, stretch that, zoom in, and then I highlight the core of that frame. Now the assumption is in here that every one of these frames are the same length and they have approximately the same pause in between each of them, so that there's a delta value that's associated with every frame. If you mark the first and last one, it knows what to do with it. And once you do that, you hit the go button. It goes through all of those, and it registers the comet cores in all 10, 15 frames, whatever the number of frames are together, and writes those files out to what I call an alignment directory. Okay, so once the alignment's done, I'm going to close this. I go to a tool called Image Integration. And that tool, I pull up those alignment files, which are in this folder here. There's 10 of them. And I just hit the go button. And I'm going to let this one run. This is going to take all of those files, 10 files. It's now stacking those 10 files on the core of the comet. This will take just a minute. It's almost done. Yep, now it's 1, 2, and 3. Be done here in a second here. And what that does is generate a final image file for me to now process, just like I process a regular deep sky. The only difference is this file will not have the darks and flats associated with it, so you're going to see some artifacts. So if I do an auto stretch on this, as you can see, it's got green background just like we had before. So I'm going to go over here and I'm going to hit my automatic background extract on this file. And now I have this file, which is basically color balanced in the background. And you notice it's got the big central obstruction donut on it, and it's got the vignetting. That's because I didn't apply any flats to this. And I'm not making pretty pictures here. I'm just kind of collecting magnitude and motion data. If this comet ever gets to be where it's really beautiful, it's got a blue ion tail and kind of like Hale Bopp, I'll do a little more work on presenting a pretty picture. But at that point, I'll be able to take really short exposures because it'll be so bright that I can apply darks and flats, and I don't even have to stack on the core necessarily. So, but this is what I do for the comet data. And I'll just pull this up in a regular histogram, and we'll stretch it somewhat. Like so. Kind of get a good dark background that I like. As you can see the coma is getting pretty significant, and there's a nice tail heading off to the 730 position. So we'll hit that. That looks okay. I'm going to pull up my color, our curve transformations here, and hit the saturation, reset this. And I might pull that up a little bit to show the colors of the stars a little bit better. And of course, the comet itself will get a lot greener. But what that does is allows you to see the no, Ken, the green is because of the chemical makeup of the outgassing, cyanogen and something else, carbon. I don't. Might be oxygen. Each of them might be a little different, but the green comes from the outgassing, the gas that's coming off the core or the nucleus. No, the green sky behind it. You mean in the original one before I just did this auto background extract? That green sky comes from the fact that I'm using a one-shot color camera that has 2 green pixels and only 1 red and only 1 blue. So its de-Bayered pattern is going to be green. When you do the background extract or the color calibration, it color balances to a white balance. So the green goes away. Yeah. So that's why you have to do that. And I didn't even do a color balance on this. I just did an automatic extract. In fact, if I did a color balance on this, it'd be interesting to show you what changes. It actually, the comet gets a little less green, a little bluer. But anyhow, that's how I process a comet. Let me pull up the luminance here. In fact, if I look at the RGB, they're pretty stacked together there. Which is reasonable. The green's a little stronger on the vertical, but not as wide on the horizontal. But I'll go with the luminance here just to darken up the background just a tad. There we go. So there's a comet shot of Atlas. So that's my processing for comets. Any questions on that? Now, obviously, since I stacked in the core and the comet's moving through the 20 minutes that I took or 10 minutes that I took, the stars are going to trail. This gets even more. You can stack these comets in DSS. In fact, you can do it. It's a 2-pass stack in Deep Sky Stacker, where it will you identify where the comet is on every frame, and then when you go and run it through the registration and stack process. It actually does it in 2 passes. It will stack the stars, and then it will stack the comet, and it will slam it together. However, Deep Sky Stacker is a little undeterministic on how well it will do that. I've had it where it stacked the comet fairly well, but it kept, when it stacked the stars, it left black halos, not white halo, black halos around it. So what it was doing was masking off the star trail to the size of the trail and then putting a single dot back on there, which kind of gives you a weird side effect of having all these stars in the field of view that are completely black right around them, and the rest of the background is lighter than it. So it doesn't look very nice. So Atlas is about 8th magnitude right now. And it's going to get brighter. It's supposed to get naked eye. It's going to pass, was it perihelion on May? Let's see. May 23rd? I don't remember. I'll have to look it up again. But if you go to the Sky Live, you can look up all kinds of objects, including any of the comets, and you look it up, and it'll tell you what the JPL estimated magnitude is. And then it gives you a magnitude below that is what was actually observed by observers around the world. And this one is listed at 14th right now, I think, but it's actually seen it to be 8.2 or something like that. So I'd go with the observed one, because these images that I'm taking are 60 seconds, and that core is really bright. That's brighter. That's an 8th magnitude core easily. I mean, the stars I've got in these 60 seconds go down to at least 12th, maybe 13th magnitude, just the stars themselves. And it's only 60 seconds. If this was a 14th magnitude comet, it would be barely on this frame. So that's why I know it's not 14th magnitude. So that's my presentation for rudimentary processing. Okay, would you use the comet mode and pick inside the planet conjunctions with? Um, I'm trying to understand your question, Ken. Ken's question was, would you use the comet mode in PixInsight for planet conjunctions with a DSLR or not? No, I don't see any reason to use comet mode in PixInsight. Conjunctions are not necessary for a 20-minute or lower total exposure. Planet conjunctions are going to be fractions of it, or seconds, not 20 minutes. You can use PixInsight histogram and curve transformation for any objects. So if you take a 5-second shot wide field or with a DSLR, you can use this histogram and this curves transformation on DSLR images, CR2s or whatever they are, raw data. Yeah, you don't even have to debayer them usually. In fact, I've got my T3I's CR2 files, and I just pull them in directly and then start processing them. Jonathan says, yeah, I see that. Thank you. Unable to connect to chat. Please try later. I don't know why that message happened there. Ooh, it's not letting me text chat. Oh, there we go. Yeah, it keeps telling me my video resolution's not optimal. I know that. By the way, is the video sharp enough if you guys got it on HD mode in YouTube?
Sorry, I popped out to the other room for a second.
What's that?
Popped over to the other room for a second.
Oh, okay. Any other questions at this point? Okay, so we've been going 50 minutes since I started the presentation. Been on a little longer than that, but and the final thing I do with these JPEG files is I put them on my Facebook and in my Flickr page. I spam the heck out of some of them that I think are decent enough to look at. Yeah. In fact, this comment is going to be in the newsletter. I wrote a little article about it. I think it'll be in the newsletter. So it'll come out in a week or so.
Be sure it will be.
Yeah, I'm not real verbose on writing articles unless I've got a story to tell. And a lot of times my storytelling in text is not very good. Usually I just get straight to the facts. This is what it is. This is what it was taken. What the exposures were, or what I took it with. He needs the Discord link. Okay, hang on. Let's see, where is it here? Is Dale in Discord right now? Let's see here. So I had a Dale show up on my list here. Oh, he needs it on YouTube. Okay. Hang on a second. Let me need to pull that out of a page here I've got.
Don't post it on YouTube because it might be permanent, and we don't want bots finding this chat room. So let me. I'll send him it in.
Okay. I want to save this. Just March 28, 2020 agenda. There we go. So that's the simple the processing for that I do for deep sky objects and for my comets. My lunar stuff's a whole different process. I do use PixInsight for some final color calibration, but when I do lunar stuff, I create AVIs. Is it AVIs? Yeah, I think that's what my ZWO creates as AVIs. They're really huge files for just 100 frames because each frame's 30 some megabytes. And I take that, I bring it into AutoStacker 3, and I pull about 25% of the stack, the best 25%, to create a final image, and then I just process it a little bit. In PixInsight, I do use the unsharp mask on that, but then I take the output of that and I throw it into Registack and use some wavelets to sharpen up some of my lunar stuff. And I'll just show you a couple of lunar images that I've got over the period of, let's see here. What do I got here? This is probably a good one to look at. So here's one that's not quite first quarter moon. And you can even zoom in on it a little bit. I think this one was a daytime one. I actually took a daytime shot. So I had to work with it quite a bit to get the background dark. But, so that's a lunar shot. Might have another one there. Yeah. This thing takes nice lunar shots at prime focus even, because the whole field of view is not, I can't fit the entire moon in my field of view. It's 27 arc minutes by 40 arc minutes. So on the short side, it won't fit. So if I were to take a full moon, I end up taking a mosaic of about 4 panels, and then this is other stuff that I do. I do plate solving of galaxy clusters. These are galaxy clusters that I've taken, and then I plate solve them to see how many gazillion galaxies are in the field of view. So that's what that's all about. It's just another thing that I do. So anyhow, and then this is a shot of my wide field camera that's piggybacked on the 10-inch. I got a 10 millimeter lens piggybacked on my Canon T3i, so I can keep an eye on the sky and how much clouds are coming in or stuff like that. And in fact, in this picture, you can see the Pleiades up there in the right, and the Hyades and Taurus right there, and then the Orion is right there into the clouds there on the horizon there. So kind of a nice little added feature. That's my skyline. That's looking over Detroit, about 50 miles away. Okay. So, any questions? Don't be shy.
Most frustrating object that you've worked on?
The most frustrating. Oh, well, yeah. I wouldn't say this is the most frustrating. This is probably the one object I've yet to be able to capture, if you want to call that frustration. And that's my asteroid. I actually tried 2 weeks ago, I think it was, because it's 18.5 magnitude. In fact, Tom, who's is he still in the channel here? No,
I
he
think
left.
he
Yeah, he left.
left.
He was with me when I started
I
imaging
I
it.
was here too for that. Yeah,
Were you?
I
Oh,
I
okay.
believe so. I mean, it was the night you were going to work. Yeah, I was here for when you were trying to get it.
Yeah, I think I finished the comments and I said, "Well, let's go after the asteroid here." And I got down to the 16th magnitude stars, but the sky was so bright over there that I couldn't get any deeper than that. I have to have a really dark sky to get to 18th magnitude or 19th. And if the sky's brighter than I'm not going to see it. So no, I went back and looked on the charts and everything, and I looked at that each frame individually, and I stacked it and everything, and it did not. I was unable to acquire even a single photon. I think of it because I think the sky was brighter than it. So that's an object that if I go up to Boone, I can give that a shot because my southern horizon's dark, and really that's what it boils down to. I have to have a dark horizon, and the sky up at Boone is SQM is 21.5 or 21.6 somewhere in there, which means that's 21.6 magnitude per arc second. So I should be able to get it as long as the integration time's long enough. And if I can go 15 minutes, I should be able to get it. And oh, by the way, it is actually moving quite quickly. I looked at it that night, and then I looked at it the next night on the Sky software, and it moves a lot. It actually moved out of the field of view in 24 hours that I had, so I had to go hunt for it, and I started tracking it. And it's moving quite a bit. So in one night, if I take a shot of it, let's say at 10 o'clock at night, and again at 2 in the morning, I'll see it move. I'll see the movement, and I should be able to, if I get the depth, I should be able to detect the movement. So, but most frustrating besides that, I actually find M42 frustrating. You know why? Because it requires really large dynamic range. The core of the Orion Nebula, the trapezium, so bright, and the little filaments way out on the ends are so dim that you got to take 5-second shots and then 10 to 20, 30, 60-second shots and do some high dynamic range processing to get that to look what people have produced. My Orions are brute force. my my Orion shots are brute forced, and they're just one exposure or two, and I just slam them in there. I mean, here's examples here, right? There's my Orion, one of them. Here's a wide field. So it's I don't even go after that. This Horset's kind of tough because you got these bright stars that are just out of the field of view that and the red nebula is takes a lot of data to pull that out. That one's pretty tough. I think the toughest one is the iris. Let me see if I that I've done so far. Yeah, this one here was. Let me pull this up, and there's a lot of data on this one too. This is 122 5-minute shots. And I've processed the heck out of this one, and I've never gotten one that looks what I consider decent. But you can see the dark lanes around the outside and in the middle area. Um, I've over processed the heck out of it to the point where it looks ridiculous. It looks very clownish. This one, I'm not sure what to do with. Not sure how to make it look halfway decent. And that's because it's a lot of reflection nebula there and a lot of dark nebula. So that one's frustrating. Oh, if he's running, I'll go ahead and 8 o'clock. I've been on an hour. I can call it quits, and we can go talk. Listen to Jeff on Facebook. Does that sound like a plan, people?
Sounds like a plan. Are we? Unless you want to just stream his Unless you want to stream his video for the people who are on YouTube who might not have Facebook. There's one question. Have you ever discovered a new comet?
Personally, no.
So Ken asked, what are you doing about the comet that's arriving soon?
The one that's arriving soon. I mean, the one I just showed you?
Think that's the one he may have meant?
Yeah, Y4. I've been imaging it all month. I've got 5 nights in it. Oh, Andromeda. Andromeda's way too big for my system. My field of view is less than half a degree. Less than half a degree, and Andromeda's like 4 degrees across one axis and about 2 degrees off the other. In fact, to give you a perspective, yeah, I like doing this one. People ask me about M31. I say, so, do you remember where M110 is? It's right next to M50, M31. Right? Well, let me show you M110. That's my field of view with M110. And it's right next to M31. So that gives you an idea of size. M31 would, I could look at the core about, but if you look at any of these pictures where it's got M31 and M32 and M110 in the same field of view, and M110 is not very big, but that's what it looks like in my scope, and that's got 2 little dark nodules in the middle, etc. So this actually turned out pretty nice. So this is before I used darks and flats. I should do this one again.
Oh.
Okay, so I'm good. We're all set. I'll discontinue the stream and
Post it in the comments over on YouTube so people can join.
did
Jeff's.
you post it there? You're going to? I can post it. I'll copy. Oops, no, I can't copy that. Why won't it let me copy that?
Post it on the.
I'll post it in YouTube right now. What Diane put in. I think that worked. Hopefully that worked. I don't know if that worked or not. There we go.
Actually, what we should see is if Jeff can join the Discord and present there too.
Whatever you want to do. My pleasure, folks. I enjoy it. I mean, it gives me something to do besides sit here and look at clouds out my window. Because for those people that don't know me, if it's clear, the observatory's open, and I've got data for over 3 years that I've collected well over 500 samples. So, but if it's cloudy, I sit here and process data, and I'm happy to do what I can to educate the best I can. So. What do you want me to do, Jonathan?
I mean, ultimately, it's up to you. I guess we could just leave a message that people should switch over to.
I think that would be
YouTube.
best. I think that would. You mean to Facebook? Right?
Yeah, unless we can get Jeff to project, but I think he's locked in. I don't think he's paying attention to the messages now. So
well, let me go look at what he's doing here. Let me just look at what he's doing here. Hang on. See if I can
just lift it off with a Saturn V.
Tonight, I don't have his link. That one's different than that one. So where's his? Where is?